glass test tubes that you're going to use are thick-rimmed. They call it boiling tubes. That means you can take this and heat it. Obviously not direct, always slightly askew and moving it about, otherwise it bursts. But it can take high heat. I'm going to give you in any case this for every chemical test, except the large ones that you use for biology. They're not boiling tubes. Don't heat them excessively, they will break. So the other thing that you will always read in your instructions is that they tell you add 1 cubic centimeter of something to your test tube. So 1 cubic centimeter is literally that. It's a little pinky. If you have a pinky there, that's 1 cubic centimeter. Second thing that you must always remember when working with iron tests is label. So this is my first one, and this is potassium iodide. So I'm just labeling it. We're testing for the 3 halogens. The next one, and don't mix your droplets. Usually you'll have a little bucket with water to clean it as well, and that's going to help. So again, 1 cubic centimeter, more or less a pinky, and you're okay. So if you do pinkies, you're good. You can do pinkies. You can do pinkies.
I can do pinkies.
So if you can do pinkies, then you know you can do chemistry. And the last one is sodium bromide. So how do we test for it again? We use nitrate. And what colors do we expect? I'll answer that as I add the solar nitrate first, because that's going to give you a telltale sign. So here's my silver nitrate. So as you will get it, it's a little small because we don't have to add a lot. So let's see, and we'll do it in here. What color is that? Oh my goodness. What color is that?
Like a pale yellow.
It looks like a pale yellow. So if it's a pale yellow, we expect it to be iodide. Oh, okay. Let's see what the next one is. So we'll compare all 3 to see. Oh, that looks quite white. So we should have chlorine in there. And the last one is my bromide. So let's see, is there a big difference? There's not a huge difference. If I have my iodine, I have my bromide, and I have my iodide next to each other. There's not a big difference, is there? How can we make sure about the difference? There's one more thing that we can add.
Solubility in ammonia.
Solubility in ammonia. Right, so how does that work? Which one is soluble or which one is insoluble?
I can't remember.
Well, let's test.
Yeah.
No. That's the thing that we're going to do. Okay, so we know the white one is at least my chloride. So let's add my, so my chloride is soluble in ammonia. This means my iodide will be insoluble in that. So it's a yellowish, which stays a yellowish precipitate. So I'm adding the same amount. Let's see what happens to my bromide. Now, our theory says that it is sparingly soluble. That means it will get a bit lighter with concentrated ammonia that's in there. And it does, doesn't it? There's still a precipitate, so it's not completely as my chloride, but it does dissolve. There's still a bit left. There's a bit murkiness in the water. Cloudiness, let's call it cloudiness, because they like preferring cloudy. Solution is still cloudy, it means there's still a precipitate. Okay, so this is the easiest. Oh my goodness, ammonia stuff.